One more example of structs. Let's extend our player struct so that we can build undo for player movements. Undo is a great place to use a stack because the action we want to undo is the most recent action, and undo goes backwards in time from there. So we need a stack that can hold movements. All of the stack we've built up to this point have held characters. Then, when a player moves, we push the move onto the stack. When a player wants to undo a move, we pop the top move off the stack to find the one that needs to be undone. To do this, we're going to have to build a few files. Move.c and .h will have all of the code related to moving, including the stack operations that we're used to having. For those, the code is almost exactly the stack code we built in the last video. The only difference is that I've built an enum that lists the possible moves a player can make, and I made the array in the stack hold those enum values instead of the chars that we've been holding. Notice that the stack is always move history size long. I've defined that to be 50, so players can only move until up to 50 moves. Note, this implementation will fail to push after 50 moves. If this was real life, we'd have to deal with that. However, the point here is to show how a stack could help with undo. I'll leave fixing that problem to another video when we have some more tools to deal with it. Our push and pop functions look just like they used to look, except that we're storing move directions instead of chars. We will also have player.c and .h to hold things that are related to players. For now, I'm just expanding the player struct that we built earlier so that it also contains a move stack. This way, each player will have their own move stack that will hold the moves that the player makes. Since we added to our player struct, we need to fix up the function that creates an empty player. This code is the code that we already had. I added a call on a function to initialize the stack. Since it's stack related, we'll put the implementation of that in move.c and include its prototype in move.h. In setUpMoveStack, we pass a pointer to the move stack into this function. It's an input-output parameter. First, the function initializes the whole array to have no movements, which really isn't necessary if we'd never made a mistake, but it's cleaner than leaving garbage in our stack. And then it initializes the top of the stack to be -1. Notice that I use an arrow operator because the stack is a pointer. Now we've set everything up, so we're ready to use the new move stack. We need a function that moves a player. We need to tell it what player to move, and since we're going to have to change the player's data, that parameter has to be an input-output parameter. It will also need the direction the player is moving. If we built that function, we could call it like this. Wait a minute, if we're going to move a player, we better know where they are. I'm adding x and y coordinates to our player struct and initializing them to 0 in createPlayer. Now we're ready to talk about moving the player. I'm assuming that the player lives on a grid where position 0, 0 is in the lower left-hand corner, and x is the horizontal position and y is the vertical position. Our move function is given the direction the player is moving. We could use a big if-else structure to figure out how each direction affects the player's x and y positions, but that's yucky. Instead, I'm going to declare a rectangular array that encodes the change in x and y for each direction. The change in x will be in column 0, and the change in y will be in column 1. Remember that enums are really integers, so no move is 0, north is 1, and so on. The rows of our rectangular arrays correspond to the move directions. So no move causes x and y to both stay the same, a change of 0. North will be 1. So moving north causes no change in x, but y gets bigger by 1, and so on. With that table, our move function can change a player's x and y positions just by adding the appropriate values from the table. The row index will be the move direction, and the column index will be 0 for the change in x and 1 for the change in y. Now that we've moved the player, we just need to store that move onto the stack. That just requires push. For undoing a move, we just have to pass in the player who wants the undo. It has to be a pointer to that player because we have to be able to change values in the player's struct. The first thing we need to do is pop a move direction off of the stack. We get the player's stack using the arrow operator to chase the player pointer and get the move stack field. But pop needs a pointer to that stack, so we need to also use the address of operator. The second parameter is a pointer to the place where we want the popped move to be stored. Once the pop gives us the direction, we just have to subtract the appropriate change in x and y using the same rectangular array that we used to move. Done. If you want to see the actual code for this, I've put a paste bin link in the description of the video. Have fun!